Hello viewers, I am Shubhasri Maiti from Shravya Institute of Modern Science, and today topic is EBNF or Extended Backus Norm Form and Dynamic Semantics. Okay, so let's start the video. Okay, so I want to tell all of you that I have made this video especially for MSC Computer Science first year students, and I made this video so that you could understand whoever not present in my class and could get concept later, and it will help you for self-study. Okay, so first in previous video I have told you about BNF or Backus Norm Form. I hope you understood it. If you don't, then I'm repeating that the basic difference between EBNF and BNF is that EBNF is actually built up or necessary to overcome all the limitations of BNF. Okay, that is Backus Norm Form. So in BNF, what you are doing, you have to keep one LHS, that is left hand side part, and one RHS, that is right hand side part. And in left hand side part, you have to keep one non-terminals, and in right hand side you may have terminal or non-terminal, and you should have to use the abstraction. That means how you are doing the program, that is not the main motive. The main motive is what actually you need to do, okay, for any given program. So now EBNF has also some kind of rules. So here actually the rules I'm telling one by one. That is, here actually the optional parts are placed into brackets. That is the third bracket. Okay. Now example as similar to the previous example, like if condition 1, then if the logic is satisfied, then my statements will be executed. In this way, actually the same thing could be written with the help of parentheses and separated with vertical bars, okay, or operation, as here I have written that like term, okay, which is assigned to term with the help of either getting plus or minus with the constant term. That means you can add these two terms, or you can subtract these two terms with the constant term. The two different lines are actually have been summarized to the same line with the help of bracket and plus and minus operator, and in the OR bracket, and with the OR operation or symbol actually. And here actually repetitions like 0 or more should be kept in braces. Okay, so here actually you can write like statement, then semicolon, then statement. This means this semicolon represent actually 0 or more, not 0 or more. Actually this semicolon means we have repetitions in program line. Okay, so for repetition, if you write like star 0, that if you write star, that represents 0 or more. If you write 1, if you write plus, that represent 1 or more. So in that way you can write like you can write like digit in third bracket, then you assign 2, again digit in third bracket, and in the power if you write plus, that represent digit value is 1 or more digit, and in power if you write multiplication sign or star sign, that represent digit, the value of the digit becomes 0 or more. That means in power if you write multiplication operator, that represent that the value of that variable actually start from 0, and if you write plus operator in the power, the value of the variable actually starts with 1. In that way we are implementing the repetitions like other programming language here. Okay, now here I have provided one comparison between BNF and EBNF. Here actually in BNF I have taken one EXPR or expression. Actually this symbolizes one kind of non-terminal. Okay, now first get the concept what is terminal and non-terminal. Terminal means where we don't have the opportunity to partition further, and non-terminal means like if you consider one kind of graph or branch for a tree, in case of data structure we have several kind of forks or several kind of level, okay, like in tree structure. So non-terminal means we have the opportunity to separate further or to get the forking further, but terminal means we don't have any value or any type of scope to partition or to fork further. Okay, now in BNF I have written like actually I am adding one terminal with one non-terminal and subtracting one terminal with a non-terminal, and here ext represent one kind of non-terminal. And so here actually what I'm doing, first see here, this non-terminal actually, okay, this means assigning, okay, this arrow represent we are assigning some values of non-terminal. So here actually first I'm adding one non-terminal with terminal, and or this means or we are adding that non-terminal with the terminal, or we are representing or assigning the terminal itself. So here actually in BNF, see here we are using three different lines to represent three different kind of operations. But in extended BNF, you can represent the entire operations by writing only one line. How? See here. Here the non-terminal you have written same like assigning sign, then terminal, then in the bracket either we are taking plus or we are taking minus, then we are taking the terminal itself. So see here, in bracket we have written here either plus or minus or terminal. That means this expression, okay, either added up with the terminal, or this expression or this non-terminal part either getting subtracted with the terminal, or the expression which is assigning to the terminal itself. That means the three different line we have represent by writing only same line. Fine. So here see here we have written three different line and getting the representing the entire thing by writing only one line. Okay, so here is the main comparison between BNF and EBNF. Okay, now I'm coming in the dynamic semantics part. Okay, so here actually in dynamic semantics what we have to do, we dynamic semantics means we have different kind of semantics like axiomatic semantics, assertions. Those are things are there in dynamic semantics. Okay, so previous semantics I have already told you that semantics represent the meaning of the syntax. Okay, so in axiomatic semantics actually was defined to check whether a program performs the computation described by specification. Okay, that means it helps whether we can check that what we need actually my program is going that way or not. Okay, and axioms or inference will allow the transformations of expressions or to the other expression, which are called assertions. In assertions actually axiomatic semantics based on mathematical logic. The logical expression is called assertion. An assertion before a statement or a precondition states the relationship and constraint among variables that are true at that point in execution. An assertion following a statement is a postcondition, and the weakest precondition is the least restrictive precondition that will guarantee the validity of the associated postcondition. Now I am going to the assertion part again and giving you the example. See here, in assertion if the weakest precondition could be computed from the given postcondition for each statement of a language, then reliability could be constructed from programming language in that language, and the postcondition for the entire program is a desired result. An axiom is a logical statement that is assumed to be true. Now what is the meaning of this assertion? So for that case we have to understand the inference rule. Okay, an inference rule is a method of interpreting the truth of one assertion on the basis of the values of the other assertion. Okay, just see this example. See here we have given these two examples and we have to get the precondition for this given example. So we can do like, okay, here my limit is given, x should be less than 9. So we can write like y plus 2 less than 9 in the instead of x we can write less than 9. So if you arrange the equation in like that, so if 2 comes here, so it will be subtracted from 9 and it will become 7. Again, instead of y, we can write like from the first equation, we can write like 6 multiplied x plus 1 less than 7. And from this line, we can compute the value of, we can compute the value, the range of x. Because here actually 1 comes here, it is got subtracted from 7 and got the value 6. And now from this statement, we can find the range that if 6 comes here, so 6 divided by 6, it become 1. So my range become x less than equal to 1. So see here, using inference rule means all from the equation actually we are considering the value from the one equation is connected to the other equation, and from one equation we are getting one value and passing those value to the other equation. But that means two equations are connected here. We are first asserting, or we are computing the range from this equation, getting the value and passing the value in the next equation. Then we are extracting the precondition. That means with the help of inference rule, actually we are getting the preconditions for any kind of equations. Okay, I hope you understood it. So I hope you get my point. And if you have any query, any doubt, you can write in the comment section. Okay, or you can ask me if you have any query. And if you like my video, please like it, subscribe it, share it with your friends. For more video, please keep listening my videos and keep subscribing my videos for getting more videos.